In today's session, we will discuss the construction, working, and applications of an electric motor. After this session, you can also try to make one at home. But, why do we need to learn about electric motor? Because the electric motor is a device which converts electrical energy into mechanical energy. This makes electric motor an important component in electrical fans, refrigerators, mixers, washing machines, computers, DVD players and more. Now, let's see how an electric motor works. Electric motor works in the principle that when a current-carrying conductor is placed in a magnetic field, it experiences a force. Now, we'll see the construction of a simple electric motor in detail. An electric motor consists of a rectangular coil of copper wire. Let's label it as A, B, C, D. This rectangular coil is situated in between the two poles of a magnetic field in such a way that arm A, B and CD are perpendicular to the magnetic field. The two ends of this rectangular coil are connected to the two halves of a split ring. Let's label them as P and Q. The inner sides of this halves are insulated and attached to the axle. The external conducting edges of P and Q touches the two conducting stationary brushes X and Y, and these stationary brushes are connected to a source called a battery. So, this is how the complete setup of a simple electric motor looks. Now, let's understand how it works. When the switch is closed, the current enters into the coil ABCD through X and leaves through Y. Notice that the direction of current is A to B in the arm A, B and C to D in the arm CD. That is, in the opposite direction to the current flow in AB. We know that when a current-carrying conductor is placed in a magnetic field, it experiences a force on it. And the variational force can be found by using the Fleming's left-hand rule. If we apply the Fleming's left-hand rule to the arm AB and CD separately, we can see that the force acting on arrow AB pushes it downward while the force acting on CD pushes it upwards. As a result of these two forces, the coil and axle rotates anti-clockwise through an axis. At half rotation, Q makes contact with brush X and P makes contact with brush Y, resulting in the direction of current in the coil being reversed. Therefore, the direction of current in the coil will be dCBA. Here, this part of the device has a standard name, it is called a commutator. Commutators are used to reverse the direction of the current. Now, since the direction of current in the arms A, B and CD is reversed, the direction of force acting on it will also get reversed. You can again verify using the Fleming's left-hand rule. The arm AB of the coil that was pushed downward initially is now pushed in the upward direction. And the arm CD pushed up earlier is now pushed downward. Thus, the coil and second half make the second half turn in the same direction. And with this, it completes its full rotation. The direction of current is reversed at every half rotation, giving rise to a continuous rotation of coil and to the axle. That's all about working with an electric motor. It converts electrical energy of this battery into the mechanical energy of this coil. Now, let's find out if we can increase the power of this electric motor. First, we can try to increase the number of rotations. Can you recall the factors on which the force in a current-carrying wire depends? They are, electric current and the strength of the magnetic field. To increase the electric current, you can increase the number of turns of the coil. We have already seen that if the number of loops is more, a greater force will be experienced. And to increase the strength of the magnetic field, we can either use more powerful magnets or use a soft iron core. Because we know that the presence of the soft iron increases the strength of the magnetic field. All these factors increase the force on the coil and hence the number of rotations. A commercial motor comes with all the above instrumentations. The permanent magnet is replaced with a powerful electromagnet so that the strength of the magnetic field is high. It uses a large number of turns of the conducting wire in the current-carrying coil. And finally, a soft iron core is placed inside the coil. The coil and the soft iron core on which the coil is wound is also called armature. That's all for today. Let's quickly wrap up what we have learned. Electric motor is a device which converts electoral energy into mechanical energy. The electric motor works on the principle that when a current-carrying conductor is placed in an external magnetic field, it experiences a force. We saw the important parts in the construction of the electric motor and its working. Like how it converts electrical energy into mechanical energy, we have also seen how the power of an electric motor can be increased. Hope you got to learn new and interesting ideas. See you soon in our next section.
Subscribe now and press the bell icon. Never miss an update.